All right, so this next method for solving quadratics is called the principle of square roots, and I guess that's pretty obvious why they call it that. Just keep in mind here that this rule, the letter k, is just standing in place of a fixed constant number, and you might ask why they use letter k. Probably comes from German, just saying. Anyway, um, now what I have found this method to be a little confused, not confusing, but a little bit of a curveball. So here in example number one, I'll try to flesh this out. So you have x squared minus 16 equals 0. So we're starting out with a quadratic already set equal to 0. That's great. In a way, we're going to destroy that. This method actually sort of takes it up, takes that setting equal to 0 idea and reversing it. Oh well. So you end up with x squared equals some fixed number. That's like the k in the rule. In this case, I chose a nice perfect square 16. So the first step would be get that number. If it's not already on the right side, x squared equals that number. The next step would be take the square root of both sides. Now the idea here is that squaring and square rooting are inverse or opposite operations. Another example of opposite operations would be addition versus subtraction, or multiplication versus division. Same idea going on here. So you're taking the square root of both sides, but it's this plus or minus thing right there. That's the devil in the details. That's where the errors happen. And in my experience, I don't know, about half the students will fail to include the negative answer on this. But going along with that, in this case, the square root of 16 is a nice plain 4. And what I've done here is when I write my answers and put the box around them, I deliberately emphasize there are two answers. The plus minus is a shorthand in mathematics for plus and minus, or plus or minus. So it's two separate types of numbers. But I think people sort of look at that plus minus as some sort of symbolic blob, and they kind of tune it out. And I'm trying to not have it tuned out. Now, why is this? I mean, this is what really bothers me, is, or has bothered me, is why is it you get this plus minus showing up out of nowhere like this? Well, I tried to give a rationalization, or not rationalization, but a rationale for why that would be the case. Now, in green here on the right, I've done the same problem, but by the method of factoring. It's the difference of squares. X squared minus 4 squared equals 0. And if we did it that way, which in this problem we can do, it's an option. You notice that we have here this the zero product property coming back, and that would give us two separate solutions. And so that to me was like, okay, well, if we had done it via, or done it by means of factoring, we would have two solutions and no one would be shocked about that. Well, this is where the plus minus can be thought of as coming from. We're getting two separate answers. Okay, so in problem one, we had the option of doing it by this other factoring method, but one reason for having this alternative method of the square roots is that you can't very obviously do the square difference of squares property. In problem two, it's exactly the situation. Here, if x squared minus 7 equals 0, right, 7's not a perfect square. It's not very obvious how to use difference of squares property. It's true that the square root of 7 squared is 7, but most people cannot fathom that. So that's okay. So notice we bring the 7 over to the right side, take the square root of both sides, the magic plus or minus comes out, comes into being there, and you just simply have two solutions for x. So pretty direct. The third example and the last one, which I think will be sufficient, is this question of x squared plus 16 equals 0. Same procedure, entirely the same procedure. All I want to do is illustrate that some of the problems will involve imaginary numbers. Remember, we dealt with that in chapter 3.1. Imaginary numbers and complex numbers. Well, they're coming back here because sometimes we'll have these negative roots, negative square roots showing up. And so try to recall the procedure there, that the idea is that the square root of negative 1 is the same as I, so if the square root of negative 1 comes up, as it will in these situations, replace that square root of negative 1 with the little letter I. And other than that, it's very similar to the problem. The first problem, you have the square root of 16, and that's 4, and so forth. So I think that covers the complications. It's not very complicated, this way of doing it. It's just remembering the plus minus part. Just fixed in your mind the best you can. You should have two answers as your default. And I think always, just take that for granted. You should have two answers, not just one. If you can do that, all is good. So I think that will do it for this. I'll try to, in case I was a little too fast up here, bring this back down. And so if you need to pause the video to take any notes, you can pause now. And otherwise, I will shut down. Thanks very much.